let's go ahead and switch over to this. Hello. Let's see what's going on. We have our Exploring Rust repo over here. A huge update came out recently. Dota 2 Attitude, hello. Good morning. Update, get ourselves the latest edition, get that going. And let's go see if we can find... you've been reading Jordan Peterson's book. You're either gonna work on work or read that right now. Well, whichever one it is, have fun. Okay, so we need to go find the Rustlang update notes because a huge update came out. You're so internally confused on which to do. The decision-making process for like deciding what to do like with our limited time is just, it's always so interesting. It's really fascinating to like prioritize and like figure out what actually is the best thing to do, even if it's, you know, even if both things are important. So it's not, I know that's not helpful, but good luck figuring that out. I'm sorry I can't help you. Okay, so what's new? So first of all, Rust 2021 edition I think is here, which let's see, does that mean I can set that in our cargo.toml? So can I do 2021 now? Okay, so nothing else. Let's go ahead and try to run. Oh, so you don't actually do any of those things. You just watch chip. You don't just do any. Okay, that makes sense. Maybe. Let's see. If I want to try to recompile one of these, let's head into examples. Let's do. Which one was decently? There's none of these were like big. I've been hearing rumors that the compile time is really slow. Let's do the any. Okay, so if you don't have it already, you can get yeah, we got that. Okay, so it seems to like the 2021 edition. All right, so it works. All right, let's see what changed here. Destroy and capture. Closures now capture individual named fields rather than always capturing whole identifiers. So I did look a little bit at this a little ahead of time, and this one I think seems cool, but I haven't obviously tried this out a little bit. I think what this means, actually they have examples down here. We have this closure here, and it takes a.y. Where's our... Oh, some struct. Okay, so let's imagine it's like a location. So we have a.x, which we dropped, but a.y is still okay. And if we tried to like send in a.y to a closure, it would capture all of a, which I think we've run into in the past. Now it captures just these specific fields that, you know, are now owned by that one thing, which is, I think, pretty nice. Okay, so migrating, so we can do a cargo fix. Let's try that here. Is there anything we would need to fix? cargo fix, and we'll let that run for a little bit. Let's see, functions never used. Yeah, okay. There's not really any crazy errors. So in the examples we've done, we're fine. Cargo to Tumble now supports a package Rust version field to specify the minimum supported Rust version for a crate. Cargo will exit with an early error if that is not satisfied. Oh, that's nice. So we head back into here. So this is a package Rust version. So this is a Rust version equals, let's try something that's higher than what we have right now. So like 1 dot, what do we have? Oh, it's rest up show, I think. Active toolchain, rest dot 156. Let's try 1.56.1. I guess you need to be string. Aha, okay. So this is the error we get now. So if I say 0 or probably 1.56, then it doesn't matter what the dot version is. Then it'll be happy. Yeah. So perfect. New bindings in binding at pattern. Rest pattern matching can be written with a single identifier that binds the entire value, followed by at, a more refined structural pattern. It has not allowed additional bindings in that pattern until now. Let's see. So, or we need separate statements to bind the whole struct and also read its parts. So we have this data in row length. So matrix equals get matrix row length. Okay, so the matrix dot row length, or with a destructuring pattern. Oh, I don't think I've ever tried destructuring with instances before. 1.56 now lets you bind both at once. So matrix. So let matrix at matrix row length equals get matrix. Oh. Okay. So I kind of want to like just slowly reset some of these things. So I'm going to do updates. An update. Maybe inside of that, can I do like a 156 to 0 2021. I did, well, I guess 156.0. That's really what it is. RS. Oh, I made that. I'll make that a folder. $156.0.rs. There we go. Okay, so if I were to try this, let's do a new bindings. So I guess we can create our struct location. That's going to have our X. I suppose you also need to be public for this. And then pub y is an f32. So I want to then do this entire thing here. So let's say I had earlier created. I suppose let's create a constructor here. I mean, it's kind of silly to take in zeros. Oh, I know what we can do. We'll derive default. And we don't need that. Okay, so what do I want to do? I want to get the x and y out. So I want to say let, and this is going to be our location at location so then we tell it what it is. So this is the type. So we want the x and a y. That's going to be equal to a location default. Oh, I bet this won't work because it needs to exist, doesn't it? I think I need to do the full desktop for this. So that way I can full screen this. Okay, so if I do that, oh, this doesn't work. Because you're in, wait a second. You need to be in examples. Now will you work? Maybe? Possibly? Perhaps? I don't know if Rust Analyzer is updated. I don't know if it can handle the new version yet. Those usually get updated on Mondays, which is obviously tomorrow. So this will be interesting. Yeah, so this doesn't let me do the run here. So I wonder if it does have to be flat. Okay, so let's try. Cargo run example, and so this is going to be updates /160. Okay, I was really hoping that I could do that, but I think I have to move this out. Get rid of you. Now this works. Okay, that's too bad. Okay, it would probably be helpful to actually do something with these, like for example, debug X and Y. All right, so here's it. Rust Analyzer knows the stuff. It works fully. I guess that's not too surprising. Rust Analyzer is not yelling about it, and then this is just normal Rust running it behind the scenes. So let's see what we got here. Location is gone, right? Location doesn't exist anymore. Now we've taken ownership of these, of each of the fields. So, because like that gets created here. Wait a second, do we still have a location? I can't imagine we have a location. Unless those were copied out. We do have a location. Okay, so I have this location, but I've also destructured these out at the same time. Now, I'm a little bit interested, what if I don't implement something that implements copy and clone, which is these X and Y's do? So what if I do something like, okay, let's create a struct, like a number wrapper. So like, what is it called? It's a vector is 2 or more and a scalar. Okay, so we want a scalar. And you have just, you can just do something like this. X is at 32. Derive debug and default. Now you are going to be scalars. I don't implement clone and copy for these. So if I now extract these out, I would imagine this doesn't work. I would imagine the borrow checker is unhappy with this. Yes, okay. Partial move occurs because value has type scalar, which does not implement copy. So which one's moving first? Is it moved into here or is it moved into here? Let's run it and find out. Okay, looks like value partially moved here. So it got moved into X and Y, but then we also try to move it into here. Interesting. So this only works if we implement copy and clone. Can I do something like I just want references to these? Not that way. How about a reference here? Or here? No, okay, that makes the entire location. No, okay. And of course I could do both. I could just say let this, right? I guess it was, wait, I don't want a location, do I? Oh yeah, I don't, so I don't know how to do it if they're both in here. Okay, so this is how it works. Let location X and Y equals creating our default here. And then this debug wouldn't exist. This should work. And it does. So basically we can now bind both at once, but this is obviously only going to work if it implements clone and copy. So both but only if it implements clone and copy. Or I suppose if we are doing, let's put this into a function. So function, what is this called? This is bindings. So you can bind location X and Y at the same time, but only if it implements clone and copy. So let location and then at location, and that gives us this. This, as I go this will work as long as scalar. So that's fine. Can I do it with a reference? Like, can I just say I want a reference of this? So, reference to you. Now they're all references. Yeah, that works. Okay, so clone and copy, or if we are getting by reference. Now I suppose that if I was trying to do this by mutable reference, this would also not work because it violates the multiple out of two multiple references. Yeah. So we can only just do a reference or a move. All right, so that's good to know. This was actually allowed in days before Rust 1.0, but that was removed due to known unsoundness at the time. But now the borrow checker is much better. Nice. Okay. Next up, so we have. Okay, so trait implementations have been stabilized. So we need to, including an unsafe cell thing, which we have looked into. Let me make sure you're, okay, I am looking the right thing. So I want to find, Trute, I don't think we've looked at, but I have it, right? I do, we haven't looked at you. Unsafe cell. We have looked at you. So added into this now is raw get. Oh, these are not trait implementations. These are just the full implementations. Gets a mutable pointer to the wrap value. The difference from get is this function accepts a raw pointer, which is useful to avoid the creation of temporary references. The result can be cast to a pointer of any kind. Ensure that the access is unique. No active references, mutable or not, when casting to mute T. And ensure that there are no mutations or mutable aliases going on when casting to reference to T. This is not unsafe. It takes unsafe, but it itself is not unsafe. So what is that? Unsafe cell. Let's go to the top, right below main. Okay, so it's immutable. Okay, so we have some examples here. Gradual initialization of unsafe cell requires raw get, as calling get would require creating a reference to uninitialized data. Okay, so we do maybe uninit, unsafe cell I32, uninit, okay. I see that's a type that was passed in. And then we're doing a raw get on, okay, so unsafe cell raw get. We pass in this M, which is this maybe uninit, which has been uninitialized with an unsafe cell. Okay. But then we're going to write 5 into it, so then we can assume init after it's been written to. Oh, so we're not having to do all at once. I think that's what I was trying to say. So if I do like let raw should I do, yeah, let's try to do this like with a location type thing. So that our location is equal to, I don't know if I can. We can do our maybe uninit. We're gonna use unsafe cell. And inside of here, we're gonna have a location. Now, we're gonna just say, okay, you're uninitialized. You don't give me any data so far. Okay, cool. So then, okay, I guess it knows what it is. It just is not telling me here, which is interesting. Then we're going to do the raw get to it. So let's break that out. Let's do unsafe. So that I guess it's gonna be our pointer equals to location dot. Oh no, it's unsafe cell raw get location. So okay, you're an unknown, but I don't have to tell you what you are. Oh, M as pointer. Okay, so M. So location as pointer. There we go. Okay, now I have this star mute location here. I should be able to set that now. So pointer dot x equals like 10.0. Pointer dot y equals 20.0. And then I think we can just do the assume init now. Okay. Then we can almost shadow this again. So that location is equal to, I'll just do this unsafe block here, and we're going to return a so it's that initial location dot assume init. I need to dereference. Oh, right. I need to do this entire thing. Right. Dereference you like that. Is it really like that? Or is it like that? It's like that. And I can debug the location at this point in time. So if we run this, it is, oh, it's an unsafe cell. I guess that makes sense. Can I make this be, I guess it doesn't really matter, does it? Can I just dereference into it like that? No. Oh, because I have to like get mute out of there. I remember there's something I can do. I can do like a get, probably get mute. Will give me a mutable reference to location. So you need to be mute here. Then this should work. And then I have access to it. if I do get, it gets me the pointer, which is not necessarily what I want in this case. But that is a way for us to do this with whatever we want to store in there, which is nice. Okay, so that's our raw get. We also have this buff rider into parts. Have we looked at buff rider at all? Okay, so okay, but I'm getting ahead of myself. So Raget takes a pointer and returns a star mute. That can be used to fill out like complete structs, like initialize whatever is in memory one line at a time. Okay. Why do I have that? I don't need that. No errors, no warnings. Let's bring that back into you. There we go. All right. Just to make you happy with, I don't have to say like no unused code. Okay, so we're good there. Let's add you first. Okay, so let's do one at a time. All right, so 156. This is, I guess, like we're doing this over and over again, so I don't really need to worry about that right this second. We have this cargo.toml. Well, sure, fine, I'll add everything. Okay, so what do we do here? We are updated to 1.56.0, which is 2021 edition, and I guess like we're looking at unsafe cell, so and raw get. You still have some issues. Oh, transmute from, okay, so we need to add in a allow Clippy transmute and char. What? Oh, I probably don't do it there. Put it up here. What? Give me that. Probably should allow instead of warn. Okay, so print size of any type. Oh, let's turn you all on again. Okay, excellent. No more warnings. We do have to read get. So this is added in, or like fixed warnings. All right, Epic Blarg, hello. You're splunking through standard. How many times have you discovered something thinking, this, I can make use of this in the ECS engine? Actually, several times now. But then I went and like tried to do it, and I don't understand it enough to be able to add it in and like actually have it improve the ECS engine. I think that's like my the big problem that I have right now is I don't know how to like I think of like, okay, this can be useful, but then I don't really know how to use it properly. It's just a feeling of like, I think it could be useful, but then I need more. I think I need like more tools to make like, then just piecemeal, oh, this one thing could be useful. All right, so we've got you. Let's come back to here. So we just did raw get. Buff writer, I don't think we did it all. Yeah, we didn't look at that. Core panic. Oh, okay. So, unwind safe, ref unwind safe, and assert unwind safe are now in core, as opposed to only in standard. We've been going through standard, so we're fine with that. Vectors. I don't think we've gone through vectors at all. Yeah, we haven't gone through vectors. Strings, I don't think we've gone through strings. Not yet. An OS string, I don't think we've done that either. Now that's interesting. I see an FFI OS string. Is that really what it is? Is OS string an FF? It is. Okay, I see. This is in the FFI. Path buff, shrink to. I don't think we've looked at path buff either. No. Binary heap. One of your employees is working on a map generator and you tried doing some unsafe optimizations and got a 4% improvement in performance. You're honestly afraid to encourage them to use unsafe. You're not sure how to handle it. Here's my honest suggestion for like how to work with unsafe with Rust. Now, huge caveat, I'm new to unsafe myself, so take this with like a mountain of salt. But I think that anytime we pull out unsafe should be a team pairing session. Like, no, it's not like the standard one person codes and then you review that code afterwards. Like, pair it together. Because if there's any weirdness or you have any weird feelings about that, that's the time to bring it up and like do the research or like call a halt to it. You don't want somebody going off for like a couple days and work on something only to find out like, yeah, I don't really feel good about this anymore. So I would do that. Like I would pair all unsafe code, all critical stuff really. Darth Millennial, hello, happy Sunday. Okay, so we're in binary heap. That's over here. VecDQ. Oh, come on. Vec EQ. Don't think, yeah, we haven't done that. Rest is about more than unsafety to you. I could see that. You mean more than safety? My motivations are more the general cleanup versus C++ traits in a match. No stupid header files. Oh god, the header files. I remember those. I don't like those. You'd use Rust even if it was unsafe? Oh, so that's a hot take that a lot of people don't agree with. But it's super interesting. Does Rust provide something beyond use of unsafe? And I would say like it does. It's like a lower level language, but also acts as a higher level language. Even if it didn't have those like safety type things, I just really like the programming ergonomics of it. Is like what I like about it, but I don't know if you can like easily remove that from the borrow checker anymore in my mind. Like they're so together. The safety slows us down as I think it was designed to. I believe so. Okay, hash map. So we haven't done hash map yet. Hash set. Which I don't think we've done that either. Yeah. The following previously stable functions are now const. Oh, so standard memory transmute, which we did look at, is now a const. So it's a constant. But I guess it doesn't really mean anything. Like we had a transmute. Can I run that? So, what was it? So here's the transmute. If I do a cargo run sample transmute, yeah, everything still works. So there's really nothing different except it's now a constant. At least from my general non-super knowledge. So it's interesting, but I don't think it really affects like learning and spelunking into the standard library. Your dream language when you were younger was C with container abstractions, and Rust is kind of like that. Oh, nice. I never got into C far enough to like hate it. If that makes sense. So it was sort of like a learning language for me. Like I did like a very small amount of real stuff, but like it wasn't big enough to actually cause any, like to make me dive into the deep depths of C. So in your world, you test it with bounds, checks, and debug mode with exhausted test cases, then do an unchecked array indexing because you're confident the indexes are correct. Nice. Yeah, there's so many different ways to like ensure that applications that we build are actually doing the things that we say they want to. There are other changes in Rust 1.50 release. Check out what changed in Rust, Cargo, and Clippy. Okay, so Rust, Cargo. I don't know if we need to look at Clippy. Is there anything else? Union field access is permitted in const function, which I don't think we ever looked at const function at all. Do I even have a const function? I don't think I do. I don't even know if that's standard library stuff, but let's I don't know where this would go. Let's create a new page for it. This is just like, I don't, language? I'm gonna create a page in here. This is gonna be a const fn. Davros, I have, I don't know if I'd have time to like look at it on stream, but I do have a Discord. If you want to join that and then send it to me there, I'll look at it off stream. I don't really have time to sort of like do any type of code reviews these days, or like just like giving too much feedback, but I'd be happy to take a look, just sort of like to see what it is. Okay, so we're gonna look at that later. Okay, so we upgraded to LLVM 13. Now I've heard that LLVM 13 is really slow. Like this is like the culprit with the slow compile times. I don't know that myself. I haven't obviously done anything big yet, so we'll see how it is. We'll also see if there's going to be a fast follow for like doing something to speed it up. But if it really is LLVM, then we're kind of hosed. Okay, so support memory address and thread sanitizers on Arch64. I don't know if I've used Arch64, so I don't think I care about that. Allows specifying deployment target version for iOS targets, which is nice. Again, I haven't done too much dev stuff. Video link, the code isn't even open yet. Oh, okay, yeah. If you send me the video link there, I will I'll gladly take a look. Warnings can be forced on with force warning. Oh, wait, so can I turn on all warnings even if I've turned them off? Is that what it's trying to tell me? So like right now, if I do, we do this, we allow you, right? We allow you to happen, even if you're a warning normally. So if I do cargo run example transmute, and what did you say? It's force warn. Okay, so not there. Here? Oh, it's cargo fix. Can I tell it that I want an example, like cargo fix example transmute? Do I have to like tell you exactly where to go find it? So examples transmute. No, I think this is meant for like normal projects and not just this empty project that I don't really have. Oh, okay. So promoted Arch64 Apple iOS to tier 2. If I remember correctly, tier 1 is, it's guaranteed. Oh, it's a compiler flag. Oh, you're right. I wasn't even paying attention. It is a compiler flag. So that is okay. So cargo fix runs it. So I'd have to manually run this with like a Rust C, and then I can add with a force warning. Okay, interesting. Okay, so if I remember correctly, the tiers are tier 1 is guaranteed to work. You can compile to it and not worry at all. Tier 2 is mostly guaranteed to work. But you should probably still test it and like, and look at that. And tier 3 is like it's on its way to like going there. And tier like anything that's not in the tiers is like you need to figure it out on your own. I haven't looked at is the M. I think I read that the M chips, the Apple Silicon chips, are at tier 1 now, but I don't remember anymore. There's this platform support page which talks about it. Yeah, so here's like tier 1 targets guaranteed to work. So there's this. Now, x86, that's Intel still. Oh, so it's not tier 1. ARM64. I think this is Apple Silicon, so it's a tier 2. Okay, so it's a tier 2. Tier 1 also means they run all the tests on all the builds. Oh, okay, so that's why it's guaranteed, because it is being tested by the Rust team constantly with every version. That makes a lot of sense. Tier 2 is like gonna slowly work there. So I think Apple Silicon, so this is the M chips, are getting close, like clearly getting close to tier 1, but they're tier 2. Tier 2 targets thought of guaranteed to build, but often work to quite a good degree in patch. So like you can see the language here is starting to become a little bit fuzzy. Devros, to eliminate the unsafe indexing for graphic eyes, I think you need some fancy index data structure collection classes along the lines of graphs, like meshes equals hypergraphs. You could certainly segregate the unsafe, but you'd have a lot more names to learn. Yeah, I bet. For graphics, oh man, oh, that's what he meant, graphics. Yeah, I am not good at graphics stuff. That's why I keep on using things like GGEZ. I haven't paid much attention to it. Okay, so allow writing of incomplete UTF-8 sequences via standard error on Windows. Okay. It doesn't really affect me very much. I haven't run very much stuff on the Windows. Usually if I run the stuff, if it's like the game stuff, I'll run that on Windows. Everything else gets through like the Linux stuff. Prefer Atomic U over Mutex for instant backsliding protection. We haven't used Atomic stuff yet. Implement extend AB for extend A, extend B, okay. Implement default copy clone for standard IO sync and standard IO empty. You get a long way with some kind of struct polymesh vertex with a bunch of iterators. Oh, I mean, I guess. I haven't, like, as I said, I'm like, the actual low-level graphic stuff, I am so, like, not knowing what's going on. And I've been okay with that so far. I guess like it's just I only have so much time in my life, so I don't have time to learn that right now, but maybe someday. Okay, so impl from array k. Okay, so impl from an array of tuples key value n for all collections. Wait, is that something that's in the standard library, or is that something that's now supported for libraries? Oh, okay. So that's now in the language. That, I think actually this is nice, because now There's some, we can start using tuples for like locations and other things, which is just pretty nice. We'll probably get to that when we get to those collections. Remove P unpinned bound from impl future for pin. So if you remember, we haven't looked at pin very much yet because we need to learn async await stuff first, or at least we need to learn our futures things. And we're not there yet, but it is interesting to see that they've removed this unpin bound on impl future. Is that the only thing in the standard library that doesn't implement unpin? Because I remember John Hu's video, he said like pretty much everything in standard library implements unpin. It's just our own stuff that may not. Treat invalid environment variables as names as non-existent. Invalid environment variable names as non-existent. Previously, the environment functions would panic if a given variable name with an internal null character or equal sign. Oh, that actually is pretty large. I had no idea that existed. So if you somehow had a system, so imagine that we had created a Docker container or like a Docker image, and it got super popular, and then we could have just like put in an environment variable that gets injected into that image that's like got a null something, and it would have panicked every single Rust application out there. Not cool. So that's actually nice. We can now run things in environments which we don't fully control, and environment variables for, which, you know, to be honest, is most of the time for running on the cloud. And we don't have to worry about those cloud providers screwing us over by accident. Stabilized APIs. Okay, so we saw this chroot, raget, buffwriter into parts. Okay, that happened. We looked at all of these. Let's see. Warn when an escaped new line skips multiple lines. That's actually probably pretty helpful. Like in case we somehow do that and like do it like skip multiple lines or somehow. I don't know how we would run into that issue, but it would be nice to know if we were going to get to that. Okay, so just like system information will be a little bit more predictable. Internal changes. LLVM is compiled with PGO in published x86-64 unknown Linux GNU. Okay, so improves performance of most Rust builds on Linux, I would assume. Or maybe just most Rust builds, I don't know. Unify representation of macros in internal data structures. Fixes a host of bugs with the handling of macros by the compiler as well as a Rustdoc. Is Rustdocs gonna get better with macros? That'd be nice. Okay, and then older version stuff. Okay, so cool with that. Okay, Cargo 156. What changed here? So obviously we support the 2021 edition. That's nice. We have that Rust version field, which we looked at. Added the env table to config files to specify environment variables to set. Wait. What? Hold on. The env section allows you to set additional environment variables for build scripts, Rust C invocations, cargo run, and cargo build. So Okay. Why would I want to do that here? By default, the variable specified will not override values that already exist in the environment. This behavior can be changed by setting the force flag. Oh, okay. So I want to take a look at that. So let's. So the order in which you put stuff into cargo the toml doesn't really matter. It's like all an object. But I would be interested in, everyone, do you have preferences for orders you keep your cargo.toml in? Like, do you keep, I always usually keep dependencies at the bottom. No matter what language I'm doing it, like, was it package.json, bottom. Like the gem file, bottom. Like all that stuff down at the bottom. And then everything else comes up here. So if I do env, and then we're going to have this, so test env equals hello world. So if I do that, now let's grab in examples here. We're gonna do a I guess cargo toml like env. I feel like I have to namespace these now. It's like cargo toml env. So what were the ways to like get the env? Because I forget what they were. It's let the test, what did I call it already? Test env equals standard, was it OS? No. Oh, standard N. Args. Returns the arguments that, oh no, that's args. Standard environments. Was it vars? Returns an iterator of variable value pairs of strings for all the environment variables of the current process. Okay. So I want like a specific one, right? Oh, var, I think. And then I give it a key. Okay, so the key would be this. You give me a result, so let's go ahead and do I can just question mark you. We're gonna do a result with a, what was that? I don't care, and then a, what are you giving me? A var error. Okay, so then I want you, and we're gonna debug test environment. So if I run this, error not present. Okay. Isn't the env section for env? I guess. Thought maybe it would work with this for run, but you might be right. But yeah, cargo run. Oh, maybe I can't do this run with it. Maybe I have to do cargo run example cargo toml env. No, still not present. I haven't tried the env macro yet. That could also work for us. I also wonder, does this need to be in like main? So like if I come back to here, I'll just copy all of you and head into the main library. Okay, so if I do main and live, okay. So no, let's actually change this. We'll do main.rs. I'll throw you in here. Okay, so if I do a cargo run, still not present. Okay, let's try that that env. So if I do let test env is equal to, so env test env inspects an environment variable at compile time. Okay, so that all makes sense. And it gives us the string. Okay, so if I run you, test env not defined. Okay, so I'm not getting that working. Did I just not do this correctly? Yes, I absolutely can. Where am I? There is a link to that. Okay, so oh, wait a second. Nightly. Oh no, stabilize env sections and it's merged. Okay. So is the documentation not up to date? Oh, it's for build scripts only? Wait a second. Okay, so I get that for like cargo build. I'm kind of sad that like cargo run, I guess like when I read that as like, okay, I can read it at cargo run. It says Rusty identification as well. Is it a different version of Rust that I need? Do I need to use nightly for this? This is interesting. I was kind of hoping that this would show, like this would have, like allow me to set defaults for environment variables, because that would be really nice. Now, is it like weird things why I'm not following exactly what they're suggesting with like that space? I think I've got all of that here. So if I run you again. Okay, let's try cargo build. Yeah, okay. Environment variable test env not defined. I know, it did say it was stabilized. I'm in, you know what? Look at the URL here. I'm in nightly. Wait, where, can I go to the non-nightly version? How do I get there? I want to get to the cargo non-nightly. Where is the cargo book? Okay, so I'm not in nightly anymore. So now let's find ENV. Okay, the ENV section allows you to set additional environment variables for build scripts. Okay, so it's exactly the same thing. OpenSSL directory. Okay, so literally the exact same thing we have there. The default will not override values that already exist. In the environment, this is going to change by setting the force flag. Does this need to be a... Does this need to be a path? So like, hello, world? No, it doesn't like that either. Unless it's not a... Let's see, you can go back to where you were before. It's main that I care about here. Let's bring you back. Yeah, so we still get that not present. That seems to be a weird one. Like, I don't get this one. We can try forcing it. They're using this only for directories, I notice. Is really interesting. Because then you can do like this relative true. I don't know. Okay, let's copy you. Throw you in here. It's just like okay, so can I find you? No, still not present. It looks like it's supposed to set it for all cargo operations, which is so strange that this isn't working then. How about this one? So temperature, this is forced. Still error not present. Now, just to like sort of make sure that this is working, like I guess that it's a bug, if I create an environment variable. So if I do export temperature equals hello, we'll do like hello world. and then I run this again. Now we can see it's this hello world. So if I set it in the OS, it works. And if I don't set it in the OS, it doesn't work. Like if it's not there. Okay, what if it's set, but doesn't have anything in it? No, because it's overwritten. So like I would have to do something like, we have this force true. I don't know. I'm confused with that. I can't help but feel it's a bug, but also I don't know for certain that I'm using this correct. Let's go down to the bottom. Is there... Is there a flag I have to pass in? I don't know. I'm not seeing anything with it. I guess we might have to like come back to it later. That feels like I would really love for this to exist, because giving defaults to those environment variables are actually pretty nice. This would be especially nice for something like working with GGEZ, which has interesting locations for paths. It's not cargo tunnel. Oh, really? Wait a second. I'm in the cargo book. Okay, hold on. Where am I putting this? Cargo also reads config files without the .toml extension, such as .cargo/config. This seems to be talking about, look at this. Okay, this is literally saying cargo toml right here. And then here's an example with the env right in here. Set environment variable name equals value for any process run by, and let's try it. I mean, what can possibly hurt with that, right? So if I do a /l, so I don't have a, okay, so I'm going to do a take dot cargo then do a code dot cargo config. So open that up here. You need to be toml, I would assume. Let's take this one and we'll just throw you in here. Interesting. It thinks that it's Ruby. That's great. Okay, so environment var name equals value. Okay, so we'll do this one. So main, we're looking for environment var name. That seems to work. Okay, so if I change this to hello world, it's now this hello world. So the idea is that we create like our environment variables in this cargo config file, and then I can override them. There's a setting for forcing window builds to link with the static CRT, but it turns out you put it in the cargo toml instead of cargo config. Weird. Okay, so I really wish the documentation here would say that this needs to go okay. Oh, wait a second. Okay, I get it. These are configuration files. I didn't read this. Here's where they look. So in your projects, .cargo is consistent across all of them. So what I can do is I could rename you to .config.toml, but it needs to be in cargo, this .cargo. And it needs to be either config or config.toml. That's all. Then this works. Okay. Thank you, Giratoro. Okay, so this, what's the, I want you to be toml. Oh, you don't know what toml is. Cool. Okay, so I'm just going to turn off all of you, and we're going to say, this doesn't work here. Put the env configuration in, I guess it's going to be project home /config config.toml. So then we go over here, and now this is like okay, these are the fun. Okay, so these are the environment, default environment variables to use for everything cargo. Will not use ones defined here unless force is true. So then we brought in this environment variable name, and we have it set to hello world. So then what I can do now is an export default that equals, and this becomes just a like I don't know, like hi there. Now if I run this again, now it's hi there because it's been overwritten. So this is really cool because no longer do I need to create like a .env and then like bring in something sort of like deal with that. This completely removes the necessity for the .env create. To be fair, you did have similar problems as well. The docs could definitely be clearer. I think it doesn't help that because I'm streaming, I'm trying to go like a little bit faster, and so like I'm not actually reading everything very carefully, and I just like, the other problem was that when I clicked on the link, it brought me down to here, brought me down to the environment variables section. So I just started reading that. I didn't actually read from the top down. It kind of assumed that you knew that configuration is different than the toml file, like the cargo.toml, which I always thought was a configuration file, but it's not. It's something else. That's super interesting and also really good to know. So I'm gonna definitely commit this because I need to like remember this sometime in the future. Yeah, exactly. Okay, so this is super good to know because this is actually really helpful. So, okay. Okay, so patch tables may now be specified in config files. Oh, so patch. Just as you can override dependencies using patch and cargo toml, you can override them in a cargo configuration file to apply those patches to any affected build. So wait, what's... The patch section of cargo toml can be used to override dependencies with other copies. The syntax is similar to the dependency section. So patch creates oh, that's actually pretty cool. So there was a couple times when I was building out like the first versions of the ECS library. And I was like, okay, well now I need to like update it. So let me go ahead and I'll comment out the one that's grabbing it from creates.io and I'll overwrite it and I'll just like create a new section for going to, I was just going to like a local file. Patch would have allowed me to do that without commenting out. If a source is patched with a crate version that already exists in the source, then the source's original crate is replaced. Does that mean that if I have something, I don't know if I can do that easily here. I think I'll have to create like a new Rust projects. So hold on, let's go to just our home directory inside of this entire thing. So I'm in a code space. So this is basically a Linux computer running Ubuntu in the cloud on GitHub servers. So I'm in my home directory here in this. We're just gonna go ahead and create like a TMP folder. And I'll probably delete that afterwards. But what I do want to do, after I close you, is we're gonna do a cargo new, so we'll do a cargo new, and I wanna create the library. So lib of like something. Cargo new lib something else, like the newer version of that, and then cargo new patching. Okay, so this is gonna be interesting. Can I open up code here? Yes, I can. Okay, so it's going to open up a code space and give me all this stuff. Okay, so in patching, what I want to do is for this cargo toml, I want to dependencies to something, and then something else we want to override with the patch. So dependencies is going to be something equals, I think it's something like path equals something like that. version equals, what are you? 0.1.0. Inside of something, I want to source lib. Gonna have a public. Just have a struct here. So this is our something. How about this? And then I want to say like, hello, I am something. Okay, so if I do that, what did I do wrong? Telling it that it is a function would probably be helpful. Okay, yes, I know. Fine. You're not a new. It's like words. Okay, there we go. So this is just a little something here. So I pull that in through this cargo toml, and I want this version 1.0. Heck, even if I don't tell you that I want 1.0, I just want this something, which means that in my source main, I want to pull that in. So that something is equal to something, okay? And then we're gonna debug something dot, what did I call it? Words. What? Words is off of something. You're public. Come on. Oh, right. Oops. Totally forgot. Yes. You're absolutely right. I forgot the self. Okay, that works. So now if I run you, we get hello, I am something. Okay. Cool. Now I want to patch this with something else, which I want to be exactly the same. So it's as if I've like git cloned this, and I'm creating a new version of it. So hello, I am something else comes into here. And cargo toml, I want to say that you're now 1.1. So you're slightly newer version. Right away, nothing should change. You should still be. You're still going to be this hello, I am something. But in this cargo.toml for you, if I now say I want to patch, which apparently can happen here or in the config. I want to say something is equal to path okay. Really doesn't like that at all. Oh, you know what? It probably needs this to be something. Okay, hold on. Let's fix that. So for this something else, we're gonna make you the same name. It's super upset. Okay, let's try this again. Patch entry something should be a URL or registry name. Oh, okay, so I can't patch from local. Caused by invalid URL, something relative URL without a base. Okay. So I can't do this. I can't patch from a local file system. That's what I'm reading there. I can't do a patch. Which is too bad. I was really kind of hoping that this would allow me to use like local development here, like play around with that. But I would have to like push it out and then just patch from there. So I guess patch is not really for development helping purposes. It's really for, hey, I'm waiting for this to get to cargo, like crates.io. So until it's there, use this version in like Git. Otherwise, use this one again. All right. Well, it's good to know. Okay, so cargo doc now supports the example and examples flags. Wait, I can build documentation for the examples? Oh, hold on. What is that? Workspaces, exploring. Okay, so if I do cargo doc examples. For a local, you've already supplied the path to the local copy and a cargo toml, right? Yeah, I guess like I was trying to do I was trying to like do an override type thing without having to like publish something to creates.io. I would have to spend more time setting up an example for this than I want to spend right now on stream doing it. Takes one argument and examples. Okay, so can I do all of them? But yeah, I think it would work a lot better for the patch if I did it not like if I did it outside. If I did one which was pointing to Chris.io and another one which was pointing to GitHub, maybe local, but it didn't seem to like patch with local. Okay, so I did this. How can I think it's serve directory. I think that's what it's called. It is. Okay, so it's serve directory. So we're going to do a cargo install serve directory. Uh-oh. Nope, wrong one. Serve directory like that. This might take a little while to install. It's basically an Actix web application. So I'm going to go ahead and take a super fast break, and I'll be back hopefully before this finishes. So I'll be right back. I'm back. I brought Kitty with me, but okay. I guess he doesn't want to hang out with us. Hi. You just want to sit on the floor? Okay. All right. Okay, so I've got this set up. Let's go find this docs. So it's in target doc. Where does that go? It's in, where's our index? There's all of the, okay, so all of these. There's like source. Here's all of the examples. Okay, so here's like JavaScript stuff, settings, HTML. Okay, let's come here. We're gonna do a serve directory. Okay, so you're gonna listen here. So I have these ports now open, and I should be able to now go to localhost to you're both ports. Oh, okay. What are you listening to? 8080. Oh, you know what? This is the this is the IP address of the code space. That's wrong. I want to do a serve directory -L. I remember now. There we go. So let's go ahead and look in here. This is what I want. So, okay, these are just now all the files and everything else. Okay, here's that any that we have. It's not really anything interesting. Oh, you know what? I bet we need to write some good documentation for these. Let's go find the any. Because we never really considered like this. We need to do something like this. So here, we have this struct location. Can I do something like, so location that will location struct for displaying where we are. If I do them all again, you're not. Oh, I guess it's not /any anymore. Nope, stop. Just come here. Well, that doesn't seem to work. All right, you're unhappy. So don't serve from that location apparently. I need to serve from one down. Okay, so then I guess is there a where is the index.html? Here's like a main.js. I don't see an index.html. There's like a search index. Yeah, that's it. I source maybe? No, that's wrong. But these are recreated here? That's kind of weird. That feels a little bit odd. Okay. When I do the doc, you don't tell me where it's going. Interesting. Okay. Yeah, so I don't know exactly where that is, but if I come back here, we go to any, I can see all of this stuff in here. It's like anyhow, the asref trait. It's not really doing anything for me. All the HTML gives me absolutely nothing. What did you get? Oh, absolutely nothing. You got, oh, wait, hold on. Oh, you got a 404. Yeah, I don't know. I don't know how to like actually use this docs. And like make it work real. If I, oh, do I have to create docs for normal things first? Is that my problem? Hold on, let's do a cargo doc. Just create docs for everything. And then examples also. So if I do target, okay, so target doc. Somewhere there should be an index to HTML in here somewhere. Let's go into target doc. Here's this. I'm gonna do a find starting here -name index to HTML. Okay, bunch of stuff in here. So this error, all of them have that index to HTML we were seeing, but they were kind of like empty and didn't have anything in there. Is there something for like the entire crate? Which, in this case, is this exploring Rust standard library. I don't see. I don't see anything. And if I try to go into any, that's not gonna find the CSS because the CSS is out here. That's interesting. Yeah, I don't know how to properly get the docs for this or how it's gonna help. I mean, clearly I can build them, but I don't know why I would want to. Let's see. Where was that? Build scripts can now pass additional linker arguments for binaries or all linkable targets. Okay, I don't really, I've not had to play with that before. Added support for the P flag cargo publish to publish a specific package in a workplace. Cargo package. Oh, so if I have a workplace, I can just publish one of them. Nice. Added documentation about third-party registries. Actually, you know what? This is even nicer than my initial thought. This means that, what is it called? We can now have mono repos in Rust. So we can have a single repo that is the workspace that has all the other stuff inside of it. And then when you push up something, like whatever changed, that could be the thing that gets published, right? Like we can just publish the one thing that changed and everything else can stay the same. So best of both worlds. Added documentation about third-party registries. Okay, I've not used any. Added the SHA-256 checksum placeholder for URLs and registry. In the config.json. Okay. I've also not had to do this, but that might be nice for security purposes. Added a warning when a dependency does not have a library. Oh, like I added a dependency that's just a main, like it doesn't have a lib. Could be nice to know. Doc tests now support the -q flag to show terse test output. For doc test, okay. Features used in a replace table now issue a warning. They are ignored, right? Because okay, so replace has now been replaced by patch. Change that only WASM unknown mscripton executes are built without a hash and a file name. Previously it was all WASM 32 targets. Additionally, all Apple binaries now built with a hash and a file name. Okay. I've not done any of this stuff before. I cheat when I do cross compiling builds. I use like either Docker containers or I use like VPSs to like then just build for each one, and it seems to work just fine. Cargo new now generates an example that doesn't generate a warning with Clippy. Wait, did it really generate a warning with Clippy? Oh, what? I don't think I paid attention before. We just created that that one. Let's see. What do we call it? TMP. It was patching. Oh, and I completely replaced it, didn't I? Hold on. Let's just do a cargo new testing. I guess if I run you, it should be that hello world. And if I vim source main, I don't see any difference in here. So like that looks to me exactly the same as what we had before. So I'm kind of surprised. Okay. Cargo fix edition now applies specific edition lints, which is nice. Improve resolver message to include dependency requirements. I haven't needed to worry about that. Cargo fix has more debug logging. I've not had to do cargo fix at all on anything. Maybe we can try it on one of the other projects we have, potentially. Change cargo fix edition. You know what I kind of want to do? Let's try that. So if I connect to Oh, not that. Let's disconnect from that one. I kind of want to run cargo fix just to find what's wrong with the ECS library. So if I connect to here, this ECS library. We'll have to update cargo, like Rust on here too. And I'll create a branch before I do this, just in case it like does something really crazy. So let's first start with Rust app update. So you're gonna install all that stuff. Let's go ahead and give myself a new shell, and I'll get a new branch going. So checkout -b. This is gonna be updating to 2021 edition. Okay, so you're updated to 156. Okay, so if I do a cargo fix, I think it's just cargo fix, right? This will take a little bit longer because this actually has real stuff in it. Oh, or not. Oh, wait, does everything just work? The cargo test? Yeah, okay. Well, apparently everything that I have in here works just fine with the 2021 edition. So I don't need to worry about that whatsoever, which is pretty nice. Like, now this was written with like 1.55, so it's not huge. Oh, I need to tell it the edition now. Oh, you're right. Let's do that. Edition 2021. Ooh, okay. So migrating from 2018 edition to 2021. So it did all this for these files, like the tests, everything else. I'm not seeing. There's absolutely no changes here. Huh, okay. So it updated it, but it also doesn't need it. You're still 2018 edition here. What did you do? Is there like metadata in somewhere here? So now I can run. I mean, so it migrated. It's migrating over, but like, you're starting to wonder if it's broken. Don't know. Like, there's not super great feedback. Let me try. Let's see. Cargo fix help. Do I need to switch it in cargo toml over first? You try to create a dummy project that does something that definitely should migrate, like explicitly using some of the things that have been put in a prelude. Oh yeah, that's a possibility. There's not much to change. Yeah, I did run it with the last, and it was a minor update, but also like an addition. So fixed in preparation for the next edition. So that's what we did here. Oh, do I have to say, Cargo Tomal, that you're a 2021? Updating to 2021 edition. Not really. Wait, is it cargo fix? Okay, so unable to migrate any further. Okay, if you're trying to migrate from the previous edition 2018, the process requires following these steps. Start with edition 2018 Cargo Tomal. Run cargo fix dash edition. Modify cargo Tomal to set edition to 2021. Run cargo build or cargo test to verify that the fixes work. Oh, okay. That apparently is it. We did it. So then we have cargo build and cargo test, and that apparently does it. So that's actually interesting that eventually I was able to get this out. So I mean, it's nice to know that that's how it works. So I'm essentially good to go here. Don't need to do anything. Oh, I closed too many windows. Oops. Okay, so we got all that stuff. Entries in cargo list are now deduplicated. That's nice. I think previously it would show you all, like, if different crates that you were using, each you use some like rand, like this one uses rand, this one uses rand, everyone uses rand, and it would, like, every time it would like print that out. Now it just shows once. Okay, fixed. Panic with build standard on a proc macro. I don't think we've done a little bit of procedural macros, but not very much. Fix running cargo recursively from proc macros while running cargo fix. Okay. Return to error instead of a stack overflow for command alias loops. Updated curl 7.79 at 1. Okay, so I don't need to worry too much about that. Future incompatible report for nightly. That could be interesting to sort of like check before something drops. Hey, are we incompatible with something? Add the different binary name feature to support specifying a non-rest identifier for a binary name. I don't know if I care about that. Added a profile option to select the code gen backend. That's not just always Rust. Oh, Things like crane lift. Oh, what are my choices? Like that's it. I probably have to go to like the rust seat. Do any of you know what the big difference is? Hold on, I want to go to. Where's the book list? Learn? There it is. The Rust C book. I just want a list. It looks like there's a lot of changes that one would make to another. But we know that crane lift is a choice. Oh, interesting. Okay, so I'm not seeing any like full list of like what the cogen options are, unless it's not an option. Maybe it's a something else. I don't see it here. So interesting to know. You remember reading somewhere that crane lift was being used to generate code for derived macros and WASM to cache for future recompiles to be faster or something. You know, that sounds familiar too. Like I've certainly heard the word crane lift before. I just never really looked into it, like what exactly it was. I'm sort of like, I really stay more in the higher level of Rust. Like I rarely get down to the low level. So I've never really had to think about these things before, and I don't know if I'm going to think about them in the near future either. I guess it depends upon what projects I end up working on. But it's okay, interesting to know, but there's not really more for us to deal with. So that's, I guess we could look at Clippy changes. Unwrap or else default is a new lint. So make sure that we're using that. Needless continue. So if you do that, it'll tell you stop it. Crane lift is a neat project if you ever think about writing a just-in-time compiler in Rust. Oh, really? I've never written a compiler, so it's one of those things which feels really like above like my skill level. But that's probably because I haven't really thought about it and I don't really know what goes into it. Lints on XOR swaps. Lints on the result type. Oh, for map flatten. Oh, okay. No effect. Now also lints on inclusive ranges when there's no effect. That's actually nice. For no longer complains about iter and item being too similar. I guess that's good. Nixitive, if you want to do some compiler stuff later down the road, Thorsten Ball has 2 books about building compilers that don't read like 30-year-old books because they aren't. That's nice. Yeah, I don't know if I ever will get into that, but I'll probably reach out to the community. If I do, then we can like maybe do like a book reading of it. But right now, like I have too many other like actual just code things that I want to do. And I don't think compiler stuff would be interesting to learn, but I don't know how much it would actually provide for me. Similar names no longer suggest to insert or add an underscore to fix. No longer shows fully qualified type path when suggesting adding default. Okay. Now suggests reborrowing mutable references. Oh, okay, so borrow it again for a while let an iterator. Okay. All right. I mean, there's not too much stuff. I'm sure that we'll run into clippy stuff when we need to. But that is all the changes from Rust update that happened recently. So that means we can come back into here, and I kind of want to, instead of like going into these, I kind of want to like continue working with our primitives, right? Because like we did arrays. Let's add an icon. We did arrays, we looked at booleans, we looked at chars. I kind of want to just like sort of look through these all, because they're I think important for us. And then like we'll get to like the harder stuff like once we get through all of these. So let's start working on F32s. So I need to reopen you. And I want the deep dive. Reconnect into you. Uh-oh, I did not notice that. Hold on, let me go take a look at what that is. Oh, interesting. Okay, so first of all, that was let me just go ahead and put this link in here. Sorry about that, Gyotaro. But that's what that message was. Okay, let's see. Oh, this is the wrong one. This is looking at the patching and something else. I don't want to look at that. Oh, interesting. Look, it shows this temp. So I want to close you off. I want to connect to you. Wait, no. You. This is the ECS library. Why am I clicking the wrong things? I want you. Improve skills. Wait a second. No, I keep on clicking the wrong thing. This one. I'm like, stop opening that. And then I keep on clicking on the exact one that I don't want to open up. Reading skills. Apparently those are important. Who knew? Okay, so here's our examples. Let's go ahead and we're gonna do F32s, I believe. So these are primitives. So primitive F32.rs. Standard F32. It's always interesting that there's the two document pages, one for this primitive type and then one for standard F32. And I think, do they have separate things in there? Like these are all the methods. What do we have for? Okay, and here's all the constants are in here too, which are important. Because these are the things that like oftentimes we're looking for, hey, what's like, what's pi? How do I get pi? Like in JavaScript, for example, that would be on like the math library, right? We're like math.pi, math.min, math.max, and then you hand over like the number into it. This, however, is all of those things are constants on each type. So F32 has that, and F64 has its own sort of applied to it, which I think is just, it's actually quite interesting. There's also this standard F32 const module, which is, how is that different? Yeah, okay, so this just shows me, here's pi for that. But if we come back to here, and they go down far enough, I think we're gonna find the const pi here too. Or maybe not. Or maybe we do have this search, like look through that page too. Interesting. Okay, I think we do. So there's that module that we also need to look into. That's good to note down. So, now do we have like a modules section? I do, but it's not in here. So these are the standard F32 const module. So F32 const. Yeah, the consts are kind of split. I mean, kind of split, but there's some consts still. I guess there's const functions on the F32 type, but these are, I guess these are just the constant properties, which is different, which is very, very fascinating and interesting that they would do that. All right. So, let's see. This is using IEEE 754 2008. that's actually important to know, because like floating point numbers are weird. A lot of it's kind of interesting. JavaScript gets a lot of flack. So let's open up this and like take a look at JavaScript here. So if I do something like, oh, I can't make this any bigger, unfortunately. So if I do something like 0.1 plus 0.2, or maybe it, can't remember which one it was. Yeah, we get this weirdness. 0.3 and then a whole bunch of zeros and then 4 at the end. It's like, what? Where did that come from? And then this type of stuff causes weird things if you're working with like extreme precision. Like if you need, if you're working with money, for example, then this will over time make the values wrong, which is not good. Like you do not want to be writing a any kind of like money application and use any float. It doesn't matter if it's F64s or F32s. Just don't use floats for money. Bear 2 dot, as it should, yeah. This is how you rob a bank. How you rob a bank fractions of a cent at a time. Exactly. Except what happens is programmers who are not familiar with floats and like the limitations of floats and what the problems are will come in and use floats because, hey, it makes sense. We're used to this, right? I have $100 and 1 cent, and I want to now add somebody else who has like $210, like $201.02. And if we run that, then like it just weird like things happen, and then the next thing you know is that you get like a then you round that and you get inconsistent results. Just truncate it and deposit it elsewhere. So first of all, the big thing to be aware of is that this is like, people may complain about JavaScript all the time. They complain about JavaScript because you don't get a choice. Everything is a float in JavaScript. In Rust and every other language that has a float type, those same problems appear in those types. So like, just because we're in Rust does not mean that we can use floats for extreme precision. So, means that we will get fun. See, what is it? It's like fun rounding errors over time. So an example here, if I take this exact same example, and let's just go and here, we could do it side view, debug 0.1 plus 0.2. Exactly the same thing here. And that's because like we're running on IEEE floats. Like it's the same implementation, it's the same standard that JavaScript uses, that Rust uses. So something to be aware of. If we want precision, like with money, use an I or U type. I guess use at I32 or I-64 really, or I-128 to like hopefully have, you know, depending upon how much money we're working with, this will be a lot more precise. Okay, so that's like the first thing to be aware of. Or a proper fixed point number type. Are there proper fixed point number types in Rust? Do we have one? Not sure precision of the word here. You might be right. Exactness of representation. Yeah, if you want, if you want to avoid rounding errors, over time, then use I32. For example, we would accidentally steal money if we used floats, so don't. Not in a standard library. Okay, so it's like big int type things where like represents floats as like individual arrays. So like there are some tricks that people can do where you can do stuff like let my my money is equal to an array of like in this case 0 0 like I can't remember how to do the decimal points. Like maybe it would be like the dollars, use 2 ints, one for the regular part, one for the decimal part. That's what it was. So it'd be like this. I want 0 and 1, right? So like dollars, cents. And then you have to do all sorts of fun math to like then make that work correctly. Also known as 2 integers. Yeah. Put the dollars in a different pocket than the change. Exactly. Luckily, there is a lot more use for numbers than just counting our money. So for example, there's a 120F12 type, which has 20 bits of integer and 12 bits for the fractional. Oh, that's interesting. Yeah, I have never had the need to look into any of those libraries. I don't think I've ever had the need to use a big int, a library either. But those are all things like if the number system doesn't work for you, people have invented these. Like it's a solved problem. This is why we should just go back to trading cows. Well, I will give you 3.4 of my. Oh, dang it. I was gonna cut up my cow and give it to multiple people. Now we're in the same problem again. Okay. Okay, so F32s can represent some special values. So for example, negative 0.0 is a possible value. So we can get negative values, but I think can I tell if they're equal to each other? So like if I do debug, I guess it would be an assert, right? So assert that negative 0.0 is equal to 0.0. This should either fail or be perfectly fine. Apparently that's perfectly fine. If I debug this, that should just run into true, right? Yeah. So we can get negative, a negative 0.0, but also it's perfectly fine when comparing. It's gonna work out just fine. So okay, so we can get negative 0.0 floats, but that can be tested for equality with 0.0. So no need to constantly get the what is it called? Get the positive version. Oh man, my math teachers are upset at me. What is that? It's the greatest. I forgot the name for it. Absolute value. Yes, absolute value. To constantly get the absolute value before checking. Thank you. Oh, Bear, that's great. Blockchain cows. Proof of stake. Okay. Infinity and negative infinity. These result from calculations like 1 divided by 0. And normally you can't divide by 0, but apparently we can now. Like that's a thing. So we can do uh-oh. Hold on. Yep, I need a... Can I do that from here? Got it. Hit him with the hammer. I'm hoping I don't have to turn on like follower mode. We had to do that one time and that was not fun. But okay. Hopefully we don't get a ton of other stuff. Debug. Let's see. What was I doing? Oh, right. We're going to hit him with checking on your chicken. Let's see. 1.0 divided by 0.0. This should give us infinite, right? Let's see what that is. I believe I do. Hold on, let me turn you over to there. Let me like make it at least look tiny bit nice while I do this. I believe I have that set. Oh, you're not catching the right window at all. Well, that's fun. Yeah, I think I have that set. I set that up a long time ago. Where was that? That was like settings, moderation. Yeah, email verification. All chatters must have a verified email. I could do phone verification also. That's not on right now. I don't know about that. I can set all the Twitch minimum recommendation too. Let's see. All right. Well, regardless, I'll turn that on if I really need to. So let's come back to you, minimize you. You're not a fan of the voice thing. Voice thing? What's the voice thing? Oh, but you set mine to requiring phone if account is less than a week or something like that. Oh, I I could do that later. Also, this is not what I want to see. Okay, so this should give us infinity. So, okay, we get infinity here, and I should also be able to give it like negative infinity, because that's apparently a thing. So we have INF. Can I actually just create infinity? Like, is that something I can do? Is that a value? No. Is that like F32? Infinity? It is. Okay. So what we can do is that negative infinity is equal to F32 infinity. This should also be true. That's false. Wait, are you? That's true. Okay. So infinity, negative infinity and positive infinity are not equal to each other. Unlike negative 0 is equal to 0. So we can also get infinity by dividing by 0, and negative infinity. Nan, not a number. This value results from calculations like, like getting a square root. Nan has some potential unexpected behavior. It is unequal to any float, including itself. Now, this is another thing that like people hate with JavaScript, but like it kind of is just something that is a thing. So Nan. So we have Nan issues now. So if I debug, can I do F32 Nan equal to F32 Nan? This is, I believe, false. Which sucks. But I believe there's a isNan, right? So debug F32. IsNan. So hold on. I think it's going to be something like 15.0 F32 isNan will be false here. And so we can use isNan to determine if something actually is false or not. So Nan, not a number, is a thing. And just like some other languages that we love to hate, Nan does not equal to Nan. To determine if something is Nan, then run the isNan method on it. I accidentally did Control C. I hate when I do that. Nan or non. Yes. There are two representations for +0 and -0. Yeah. I think we read that up top. Yeah. Oh, it's usually Control W that burns you. I've had that happen to me too. Control W, Control C. C and V are so close to each other on a keyboard. I constantly accidentally hit them, especially since I'm not always looking at the keyboard and I'm not having my hands like on it properly. Okay. Let's see. Let's go back to you. It is considered infectious, as almost all calculations where one of the operands is nan will also result in nan. So, I mean, I suppose it makes sense, but any math done on a nan will result in a nan. Which is interesting because that doesn't mean we're going to get a result like an actual error. It just is going to be happily continuing to work on stuff, but we're getting nans all over the place, which can be hard to trace down exactly where like the nan first happened, which has happened to us in the past a few times. It kind of sucks. Okay, so let's take a look at our implementations here. So 4. Actually, don't know if I like for these, especially I need to do this implementation section, and I might just do this in the code. As we're sort of like playing around with it. So we have you. Okay, so floor returns the largest integer less than or number equal to a number. So floor makes sense. It's the same as like everything else. If I debug like 10.5 f32 dot floor, that's gonna give me 10.0. So there we go with that. I'm actually going to create a new function for this. So function implementations. And it's just going to be examples of like all of this stuff. All right, well, have a good chicken dinner. Okay. Seal is exactly the same thing as floor, except it rounds upwards. So we could have, if I do this exact same thing, but we do seal, then we're going to get 11. There we go. Now round returns like we don't have as much control. So like I guess we could think of floor and ceiling as rounding, but it rounds, but we get to control the direction that it rounds. So even if I choose something like 9, like 10.9, if I go to floor, that's always 10. So always rounds down. Whereas round here returns the nearest integer to a number, So this is actually going to be interesting. If I choose 10.5 and I round this, round halfway cases away from 0. So this is going to be 11. But 4 would bring it to 10. So let's actually do that twice. So you're going to be 10.4. And we can see 11 and then 10. Truncate returns the integer part of a number. So removes whatever is after the dot and doesn't change anything at all. So so if I debug like 3.14 f32 dot trunc, this will always be just 3. It is 3.0. It's still an f32. But I'm just dropping all of the stuff that I don't care about, which is the after the decimal. What did I do wrong? I did a semicolon wrong. There it goes. 3.0. I wonder if making these instead of debugs asserts would be better. Then we get like less weirdness out of it. Okay. Fract returns the fractional part of a number. So this is now returns just everything to the right of the decimal. And I think what's important to note is like none of these are affecting the original thing. So if I do like if I create a variable with this value in it and I get the floor of that, the original thing is still the same, but I now have something with the floored version of it, and it's new. It's not like a reference to it. It's like a full new number. Okay, so we have you, and we're going to get the fract. So you are going to be 3.14. Let's go ahead and convert all of these debugs to asserts. So assert, I want you to be equal to that. Actually, some of these will be interesting. Okay, so that one is fine. You, I don't need to worry about any trues. You just is the thing. Yes, you're true. This is gonna fail, so I'm gonna make this a not equal. Then we have our implementations. Okay, assert floor. I think what I can do is some tricky multi-cursor stuff here. Except, oops, all. Except for this one right here, because I did both these together. I need to do these separately. So just take you out. We'll do no, stop. Okay, fine, whatever. grab you out. Nope, not that far. Okay, and here is equal to that. That's what I want. So that's good there, and then these two are gonna be just unique. So you're gonna be okay, I'll just do 10.0 for right now, but that first one is gonna be 11. And I'll move you back up here. Okay, so now when I run these, we should successfully get nothing. Why don't you work? Kind of surprised that it won't let me do the run thing anymore. Is that because I need to have something? Can I have you be a test? Oh, wow. Okay. Well, apparently if I don't do that, it's not happy with this at all. If I come down here and I do a cargo run sample primitive F32. What do you mean implementation is not found in the scope? It's right there. Oh, because I put a test in front of it. I guess we're not doing that. Assertion failed. 1532 is nan. Oh, because it's not nan. Ha, it's not nan. Okay. Okay. Panic assertion failed. Line 14. So rounding. Oh, because you round. Sorry, you need to become like a 4, and you round down now. Okay, so fract. Okay, so we're now on to like the new stuff. So this fract is gonna be 0.14. Is now what we get out of this. Okay, let's do assert equal so we can actually see what we actually got. Oh, F floats. Ah! Okay, so look what we got here. This is like the fun with floats, is R left with week 3.14. And that's all I gave it. I got the fract, but it's actually 0.14000001. Thank you. And now that works. So beautiful. And I think it's like, it's just little things like this with floats constantly, like they're dangerous, but they're still useful. Absolute value. Okay, so almost everything returns nan, but absolute value. Okay, so like if we have a negative number, so if I have like assert, if I have like a negative like 15.0 F32 and I get an absolute value off of that, that's going to be equal to 15.0. Hold on. I want that. The left is negative. Isn't absolute value the absolute value of it? Makes it positive? What did I do wrong here? The left is negative. It should be positive. What are they doing here in their example? That's interesting. Okay. So if I have, that shouldn't be negative. That should be positive, right? Oh, wait. Like that, maybe. There we go. That's what I need to do. I had the parentheses in the wrong place. So if we have a negative number, and then I get the absolute value out of it, obviously it becomes the positive version of that. What's really interesting here is that any math signs that we're doing affect afterwards, right? So if I remove these parentheses, this is actually going to be negative. Maybe something just to be aware of, because that's not intuitive necessarily. Like, I'm thinking that I have this negative, but I'm really taking the negative of after ABS runs. So the order of operations that we're going here is that we're taking 15.0 and then getting the absolute value of it, and then making it negative. And then this is correct. That's kind of weird. I kind of want to note that down. So the sign takes effect after any methods are executed. So like that. So in this case, if I want this to actually like work the way I expect it to, I print the parentheses around the negative 15.0, and then I run the absolute value after that. And then this should be fine. Except now you're positive. That's an interesting one. I hadn't really thought about that. Signum returns a number that represents the sign of self. If the number of okay, so this is the sign. So like the sign of it. So assert equal here. If I just do this again, so we have our, let's not use that, and I do the signum. I think it's signum. How would you pronounce this? Signum or signum? You're going to be negative 1.0. Okay, good and that. Copy sign returns a number composed of the magnitude of self. Oh, and I guess like a reason that this one might be really helpful is if you just want to check to see if it is negative, you don't have to do this entire thing of like, let me check to see if it's less than 0.0. Instead, you can just get the get this, call this method, and then check to see if that's equal to -1.0, which is nice. Copy sign returns a number composed of the magnitude of self and the sign of sign. Equal to self, the sign of self, and sign are the same sign, otherwise equal to negative self. So wait a second. Signum, not signum. Okay. So signum. I'll continue with that. That's sort of like what my initial thought was, but then as I was reading, I'm like, but I'm getting the sign. So does that mean it's? And then I just went. They just went into the entire down that rabbit hole. Okay, so copy sign, equal to self if the sign of self and sign are the same. Otherwise, equal to negative self. Okay, so this is a way to reverse the sign, I think. So let's say I have this -15, and then I want to do copy sign, and then I'm going to give it a 1.0. Now this is going to reverse that to now make this number 15.0. No, okay, I had it backwards. So we got -15.0, and the right is, I copied the sign. So if I do negative, that's going to make it negative. Yeah, okay. Let's see how this works. If we have f is this positive number, 3.5, and I do copy sign with another positive number, we stay with a positive number. So positive, positive, positive. Negative, so positive and negative are negative, okay? Negative and positive is positive. And negative and negative. Okay, so negative and positive is positive. Wait, that's not what I saw. It's the same thing again. I have to do this. I have to do this. And then you are gonna be positive, I believe. There we go. Okay. Mul add. Fused multiply add. Compute self times A plus B with only one rounding error, yielding a more accurate result than an unfused multiply add. Using mul add may be more performant than an unfused multiply add if the target architecture has a dedicated FMA CPU instruction. However, this is not always true and will be heavily dependent on designing the algorithm with specific target hardware in mind. Interesting, okay. So, interesting. So I wonder, let's do this twice and see, because like there's two ways of getting a multiply add together. If I do something like 10.2 dot or f32 dot mul add, then it's A and B, right? So I'm going to multiply it by 2.0, and I'm going to add another, let's do like 2.1, 2.3, and I want to add 5.5. what would we expect this to be, right? So 10.2 times 2.3 is going to be 20.6, and then add 20.6 to 25, 26.1. But I'm not convinced that we're actually going to get 26.1 for real. It might be 26.1 something. We'll see. 28.96. How am I that bad at math? Calculator time. Okay, so if I get 10.2 times 2.3, 23.46 plus 5.5. Yep, that's a. Oh, did I forget the dot 5? I think I just did the 5. But yeah, 28.96. Okay, that makes sense. Now, the idea is that this may or may not be more accurate than... let's see, it's self times a... Let's see. So if I do... Is there another mul add that's not fused? Oh, wait, no. Not fused. Not fused means I do them separately. So if I do 10.2 F32 times 2.3 plus 5.5, it should remain the same here, but it's not guaranteed to be. In this case, it is because these are simple enough. But it's possible that we come up with something that's not exactly what we're going for. Also, this one might be a little bit faster. Okay. And sorry, that was my Slack. Let me go ahead and quit that out. Nope, I didn't want to do that. Okay, so where were you? Div Euclidean calculates Euclidean division, the matching method for Ramdic Euclidean. Remove. Oh, remainder. This computes the integer n such that self equals n times right-hand side plus self that removed Euclidean right-hand side. In other words, the result of self divided by right-hand side rounded to the integer n such that, okay. This type of stuff is like where I like, what is this math again? Do I know math at all? Let's see. So, okay, so it's matching this calc. So if we do this, so we have A is 7 and B is 4. So if I do A div Euclidean B 1 as, so is that A divided by 4 goes into, there's a remainder of 1. That's what it is, right? There's a remainder of 1. I think that's what it means. So if we do like 10.0 F32 dot div. I like how my code analyzer is just giving up. It's like no longer helping me at all. Okay, so Euclid, and then I give it the right-hand side. So now 5 should go in there 0, right? Like I would expect that if I do 5, I should get 0. if it really is the remainder. I got 2. Because it's 2 times 5 to get there. Is that how it works? And then okay, so you're 2. If I do 6 here, 6 doesn't evenly go into 10. 6 times, so I guess it would be 1 or like 1.5 or something like that. 1 point something. No, one is exactly correct. Okay. Now, if I change these to not be evens, like if I do 10.4 and like 6.2, this should still be 1, or is it going to be 1.1? No, it's still going to result with a something .0. All right. So it is the number of things multiplying, but not exclusive of it, right? So like if it's 6 times 2 is 12, which is greater than a 10, so therefore it has to be 1. If we switch this to like 13, it would be 2. Rem Euclid calculates the least non-negative remainder of self. In particular, the return value r satisfies 0 less than or equal to r less than right-hand side to absolute value in most cases. However, due to a floating point round-off error, it can result in r is equal to right-hand side to absolute value, violating the mathematical definition if self is much smaller than right-hand side to absolute value in magnitude and self is less than 0.0. This result is not an element of the function's codomain, but it is the closest floating point number in the real numbers and thus fulfills the property. Okay. So, yeah. Part of this thing because it's like the best that we can get to. So, calculates the least non-negative remainder of this. So, how is that different than modulus? So if I have like 10.0 and I want to do the rem Euclid, so remainder, and I want to do this for 6. So 6 times 1 is below it, so the remainder should be 4. Which that is. Okay. Now, if I do the same thing with modulus, so I think it's modulus 6 should still get 4. Which I do. So it's pretty much the same thing as this. So actually I can, to show that they're attempting to be the same, do that. Okay. Pow I. Now these ones are fun. We've actually used this before. Pow I is raises a number to an integer power. Which is kind of interesting because floats, obviously we can raise it to a floating point power, which I don't think I've ever had to do, but it's interesting that it exists here. It's also interesting that it's a method on these numbers itself. So if I do our assert equal, and we do, I think like 2.0 f32 dot pow I, if we do that 2 to the 4th, right? So that's 2 times 2, that's 4, times 2, that's 8, times 2 is 16. So that should be 16. Okay. Of course, we can also do some fun things like what about 2 dot 2? Is that going to be 16.16 or is it 17 dot something? I think it's 17.2. I haven't actually done the real calculation. Let's find out. Oh, I'm so off. It's 23 dot. Okay, is this fun number? Now that's like to pow I integer. There's also this next one out here, which is pow f, which allows me to pass in like 4.3 as what we're going for. And I'm not even going to bother to try to calculate this. I'm actually curious, can this calculator figure that out for me? I don't think... Okay, basic can't do it. How about scientific? Okay, I can do x to the y, right? So I can do... No, that's wrong. Reset. Stop. I want to do, in this case, 2.2 xy, so to the 4.3. That's what you give me. Let's see if that is what Rust comes up with. With its 32-bit, I don't think it's going to be this long, but we'll see. Okay, so we got 29.6738, and then here's where it ends. 383. Oh, look at that. 6838, whereas this is a 2. That's not even rounded that way. Interesting. So 8 becomes here. The floating point numbers. So the calculator has a different type of floating point number than Rust is using. Square root. Returns the square root of a number. Okay. So if I do, I can get square root of like something else. Like let's do like 152.2, and then if I do this dot square root, I don't know what this would be. Let's find out. You are okay, 12.336. Okay, so that's what you are. Okay, so I mean, it is nice to know that you can get the square root of like very precise like floating point numbers. It's interesting though. Exponent exp returns e to the exponential function. Oh wait, is that e something? E1? I've never really, like, I sort of like stopped with my math classes after, like, very shortly after we got into like ETH type stuff. Or at least I've forgotten all about it. Maybe I like put it out of my memory. But so if I have, they're suggesting like we do 1 1 0 F32 dot X. What are you? You're this 2.71. So it's like, can't remember what the E means. It's not raised, it's not this number raised to 1. It's something else, I think. But I totally forgot. And that is interesting. It's also one of those things where I don't know where I would use it. I haven't run into it so far. There's the exp2, so returns 2 to the self. Now that's interesting. So exp, is that 1 to 1 to 1? Well, because that would be 1 power to 1. That would be just 1. I wouldn't get that. But if I do x2, then 2 to the self would be 2, right? It would just be... Wait, what line on this? 31. Oh, I've got the wrong one here. So right is... Oh, I forgot to save. That's my problem. Yeah, okay, so left is 2.0. That's... We're back into something that makes sense to me, at least. So this is 2 to the 1. ln for logarithm. I don't think I've like had to do much logarithmic stuff on my own. Sometimes like I use stuff that uses logarithm behind the scenes, but I haven't had to do that in a long time. I know that you can use the logarithm, the log of something to sort of like help in calculating when to stop calculating, like what is it? Some types of numbers. Oh, I forgot what algorithm you use that in. It's been like so long since I had to do any of that kind of like, any of those trivia type things. Okay, so if we do, let's do like 100.0 f32.ln. Now, I find it interesting that they didn't choose log instead of... Oh, no, they did choose log. So this is the natural logarithm. And this is the logarithm with respect to the arbitrary base. Interesting. I'm interested in what the difference between these are. So... Interesting. Okay, so the log of this is like 4.6. Which is not sort of what I expected. I think log is going to be 2. So let's do log. You're either 4 or 2. I can't remember. Oh, I have to give it the base. Okay. Result might not be correctly rounded owing to implementation details. log 2. Oh, okay, so base, like if I do base 10. What are you going to be? Yeah, okay, so base 10, that's exactly what this is. I can do like base 2, base 4, base whatever, and then it like gives me the proper log. So that's, I guess that's what this is. Log 2 returns the base 2 logarithm of the number. Okay. So log 2, and then this doesn't take anything in here. What? Not binary, so it's like what, 10? I don't remember. Oh, 6.6. Oh, that's fun. I should stop guessing on these. Okay. And then log 10 is going to be exactly this same thing again. So if we replace this, we have log 10, you're going to be this 2.0. And we're good to go. Oh, absolute sub. So the positive difference between two numbers is deprecated. Okay, interesting. So that doesn't, it's deprecated, going to be removed. Okay, CBRT, the cube root of a number. The cube root of a number. What is that, like something to the third? Like something to the third. I guess, so like what? 2.0 cube root would be 2 to the third would be 8, right? So let's do 2 CBRT would be 8. No. Okay, so I'm way off. It's 1 point. What? Okay, so clearly I don't know what cube root means. Oh, the root. Okay, so for some reason I was thinking the other direction. The root of a number. So the cube root of 2. Okay, so maybe 100 will be easier. So 100, the root of 100. The cube root, what is a cube root? Cube root is x to the 1/3 minus 2? Is that what that is? No, okay. Cube root would be x to the 1/3. Okay. 1/3 of 100 would be the what? 33.33. Repeating, I think, possibly. So this should be what, 33? I probably don't have enough 3s in there. Oh, it's 4.6. Okay. I wonder if I'm off by rounding. Like there's a rounding error. Okay, so we got that. Let's see. Now that calculates the length of the hypotenuse of a right angle triangle given the legs of length x and y. So I've actually been doing this a lot, based upon two different what is it called? Vectors. Like, or like, what's the length of a vector? So having a hypotenuse might make this a little bit easier for this. So to get the length, it's what, like x squared plus b squared. So like we have our triangle. So like x squared plus b squared equals c squared. And then is it dividing that by itself to then give back to, no, because that would be 1. What is that? Oh, it's the square root. Then you get the square root of it. Yeah. So if I have like a length 5 and then 10, so that's 5 squared, that's what, 25, plus 10, that's 100. So that would be 125. Oh, I don't know what the square root of 125 is. Like 12 something? 14 something? Let's find out. So we're going to do interesting. So we're going to start with 1. So we're going to do like 5.0 F32. So that'll be our a squared dot hypot. And then this is like, okay, the b squared. So let's do 10.0. And then we expect this to be something like, I don't know, 14.5. Oh, 11. Okay, so the 12 guess was a little bit closer. So that gives us the length of the other, like the distance of a vector, essentially, which is actually really nice. I can just get that myself then. So ways in which this could be really helpful for me. And something that I've relied on other libraries to get this, but we don't really need to. It here in the library. So let's say I have my own vector. So let's do it like a struct vector. We'll do a vector 2, and you are a fx f32, y is f32. Want to impl vector 2, and so I want to get the length. So hub function length is going to just take in a reference to self, and I'm going to return an f32. In this case, what I can do is I can say self.x.hypot self.y. And that should give me what this length really is. And I don't have to do that calculation myself. I can just use this thing that already exists for me. That's nice. Okay, so sine computes the sine of a number in radians. I always forget like radians and converting from radians to like degrees. But like it's basically going to be how far along a circle, right? Like you are. So what is the like if I have 45, it's not 45 degrees. Yeah, I can never remember that, but we're gonna look that up here. So let's say we have this 45, and then I want you to get the sine of that. And I have no idea what you're gonna be. Oh, 0.85. Is that does radians go to like 0 to 1? I can't remember anymore. Like usually the first thing I do is like convert to degrees, which I wonder if there is a method on here to convert to that. That would be nice. And of course we can get the cosine too. So, I cannot remember. It's not the opposite of it, but it's something. Let's take a look here. It is 0 to 5. You're upset because I'm not using you. Let's go ahead and yeah, let's tell it that we don't care about dead code. We're okay with that. Allow what is it? Could be dead code. Maybe. No, it's colon, isn't it? Oh, wait. Okay, so that's not the problem. It's not dead code. It's strict is never constructed. What? No, I have allowed dead code. Apparently that's not my problem. Okay, hold on. Can I tell you to restart? Can you like work? Let's see. It's gonna be next. Oh, the tangent. And tan 2, I think, is what you use to like get the directions between things. Although you can also get that from doing some vector math, which is what I usually do. Okay, so you're still not. No. Although, why do I have so many errors in here? Maybe is that. Oh. Okay, now you're yelling at me about all this stuff. Okay, so equal expressions. Stop. Equal expressions operands to equal. Okay, let's change you all to assert equals. And then oh, this is not. Okay, hold on. So then you become just a comma. Okay. You are assert not equal, so that this is probably still assert. You're fine. You are also just assert. Then you are a strict comparison, so we have to turn that off. We can do a global version. So I think the way to do global stuff like this is to do a hash bang allow Clippy strict float compare. Okay, so you're not happy with this. Identical arguments used in this assert equal. Oh, identical arguments. Those aren't identical. I'm just trying to show the math. Okay. Deny Clippy equal op. Can I do this? Oh, I think I have to do above that here. So deny allow Clippy equal op. Okay. Doomed comparison with Nan. Yes, okay, I know. assert. Yes, I know it's gonna be optimized out. It's fine. Okay, so compare nan is another one of these. Can I do like multiple of these? So Clippy, compare nan. Oh yes, I can. Okay. Approximate value of pi found. Consider using it directly. No, Clippy, let me do my things. This is gonna be allow Clippy pi approx constant. So approx constant. Okay. Then you. Okay. Identical args used in this. Once again, I'm just trying to like show off the math of this. So I want this. Okay, so we have this equal op here. I want to turn this into a global. In fact, you know what I probably want to do is just make all of these globals. So copy you out, throw you in there. Then I don't need any of those Clippy things anywhere else. Okay, so the prox constant can go in here too. Strict is never, okay, so dead code, we're going to allow dead code. Oh, this one is just, okay, it's not a Clippy thing. Allow dead code. Okay, this next one, assert true, will be optimized out by the compiler. Okay, so this is also allow Clippy assertions on constants. Unary minus has lower precedence than method call. So this is really good. This is letting us know that, hey, this is what we need to do. So this is actually a really nice warning to have, but we kind of already discovered this by accident when we didn't have, Rust Analyzer working for us. So I'm going to allow this for here so we don't actually get a warning in our terminal every time we do something. But it is good to know that Clippy would discover this. So this is going to be Clippy precedence. And that's it. Okay, so now we can come back to here and run this again. And we're good to go. All right, so we're working on the tan. How many more of these do we have? We have a ton. So many things on here. Let's do tan, then I'm probably gonna have to end it because I feel my throat starting to feel it. So we're gonna do tan. I don't remember what the tan is supposed to be, so we're going to go ahead and run this, and it will tell us you are 1.6. So the tan and tan2 can be used to sort of calculate directions of a vector of like two different things. So if I have like the x and a y of something, I can then figure that out. When I first started doing a little bit of game development stuff, I was using Lua. And I was actually doing this on stream. It was very interesting because I was like, okay, I want a ship and I want it to, like, I want to click over here and I want it to move. And like, I want to rotate towards where I'm going and then move towards where the mouse is. So like, there was sort of like lots of different stuff going on there, but the big one was, how do I know what direction to move in? And this is before I understood vector math, where I can just say, well, how this vector minus that vector is the vector to go. Normalize that, multiply it by a speed, and then we're good to go. Super easy to do now. But back then, it was like, okay, I can use like this tan stuff and figure all that out. It was not fun. It was not easy. And I would constantly forget it too. So at this point, I still forget it all the time, but I also don't need to use it. I have better ways. Okay, so what I think I'm gonna do is I'm gonna go ahead and we've got this cleaned up. We've got no more warnings or errors. I'm gonna go ahead and mark this. Let's also like copy this and put it into this document. Okay, so we updated cargo to the 2021 edition. We updated those examples, and okay, these are all untracked. I guess I don't really need the main, so I'm gonna go ahead and remove that. So we just have these two. Oh, we can remove the examples cargo toml too. These environment variables that we were looking at. We don't need to worry about that. So that, the cargo config, which we had figured out elsewhere, we're not gonna put into this one. So I don't need to worry about it. So rm-rf cargo, guess, might as well just remove that. And then all that's left is now for I guess we touched any, but cargo to toml. Okay, so we're gonna add this. That git commit -am. What are we doing here? So this is like now F32s. 32s. And I'm gonna go ahead and push that on up. I don't know if I have this. Here's the exploring Rust inner library. And there is that. So if any of you want to go and like take a look at that, that's where I've been putting it. I've been doing all of this work in a code space, so it's all based upon Linux and Ubuntu, and it's like on the cloud. It would be interesting to sort of like see the differences between some of these numbers in different environments, like on Mac, on Windows, and on Linux, especially on different CPU architectures. There might be just subtle differences in like how calculate stuff. So that could be interesting. Anyways, I've been doing these streams every Sunday, starting around 8 a.m. Mountain Time and then going to around 12, which is now. So I don't have any other scheduled streams. I might do some random streams after work during the weekdays. And then usually during that time, I'm just playing a game or something like that. So anyways, if you want to see more of this, I would love if you joined us and you followed, or if you came over and joined on Discord to sort of like chat between streams. And so with that, I don't have anything else. So have a great rest of your Sunday, and I'll see you all next time. Bye.